Math 2, Unit 10, Worksheet 5. Solving quadratic equations using square roots. All right, before we get started, I want to go back and review something we've talked about a couple of times. So first of all, if we say that x squared equals 4, what are the possible values for x? 2, because we could plug in 2 because 2 squared is 4. That's true. Anything else? Negative 2, that's right. We could plug in negative 2 as well and get 4. Correct? All right. So in this case, x could equal positive 2 or negative 2. Is that correct? All right. So when we say we want you to solve for x, when we have x squared equals 4 and we want you to solve for x, what we do is we're going to take the square root of both sides. Because remember, when we solve, our goal is to always get x by itself. And right now, x is being squared, so to undo that, we would take the square root of both sides, right? And the square root of x squared is x, correct? Is everybody with me? Okay. And the square root of 4 is 2, right? But we got to remember it could actually be 2 or negative 2, couldn't it? So that's very important in this unit and any math from here on out where you take the square root of an x squared. You need to remember that your solution could be positive 2 or negative 2, or it could be positive or negative in general. All right? It's going to be very important in this unit. All right, so let's look at A. Solve the equation for x. Well, just like before, we want to get x by itself. And we kind of think of undoing the problem, which means order of operations backwards. So usually we add or subtract last. This time we're going to add 4 to both sides first because we're undoing the problem. And when we undo it, we get 4 equals x plus 3 squared. Does everybody follow that step? Okay, good. Well, the next thing would be to take the square root of both sides, right? And the square root of 4 and the square root of x plus 3 squared. Well, the square root of 4 is 2, but we're taking the square root of an x squared, aren't we? Here it is, it's x squared, so we have to remember that it could be plus or minus 2, couldn't it? And that's the symbol we use for plus or minus, with just a plus sign and a negative sign underneath it. That means plus or minus. And the square root of x plus 3 squared is just simply x plus 3. All right, well, we didn't give ourselves very much room to work here, and especially since I gave you that little example. But once we're in this situation, we've actually got to break it into 2 equations. We got to take the positive 2 equals x plus 3. And normally I'd do these right next to each other, but we also have to consider the negative 2 equals x plus 3. Do you understand how we have 2 equations at this point? Because remember, we said that x could have equaled 2 or it could have equaled negative 2 in the original situation. Yes?
So what could a 3 be negative 2?
What's that?
X plus 3, x minus 3?
Well, we'll test it out in a minute, all right? Let's go ahead and finish solving for x. So we're going to subtract 3 from both sides. And that means one possibility is x could equal negative 1, right? And if we subtract 3 from both sides here, hopefully you guys write neatly because this is not a lot of space, we end up with negative 5. So what we're saying is you could plug in negative 1 into this equation or negative 5 and you'd get the correct answer. So let's go back to our original and let's just test it out. So if we plug in negative 1, we get negative 1 plus 3 squared minus 4. And you get 0 equals Negative 1 plus 3 is 2 squared minus 4, which means 0 equals 4 minus 4, which is true, isn't it? All right, well, now let's go ahead and plug in the negative 5. Zero equals negative 2 squared, minus 4. And 0 equals 4 minus 4, which is also true, isn't it? And all of that is because x is squared. Does that make sense? All right, let's do a couple more. All right. Let's go down and do B right here. So we're going to take the x plus 3 squared. Wait, that's our same one, isn't it? Oh, we're going to graph it now. I'm sorry. We're going to graph the same equation. So if we graph it, we have our vertex, don't we? What's our vertex of this equation? Whoa, did you guys say 3? The vertex is negative 3, negative 4, isn't it? Remember, it's x minus h. So it's got to be x minus negative 3. So let's graph this. Let's see. Negative 1, 2, 3, negative 1, 2, 3, 4. Okay, and let's plug in some numbers here. Let's plug in, what should we plug in?
1, 2.
All right, we can plug in all these. How about we plug in 0? Let's see what happens at 0. So, can I do it right here? Maybe I'll do it on here. So let's plug in 0 into this guy. So we're looking for y now. So y equals 0 plus 3 squared minus 4, which means y equals 3 squared minus 4. I think we can say that's 9 minus 4, which is 5, correct? All right, so we plugged in 0 and got 5. Let's plug in negative 1, okay, and see what happens. So y equals negative 1 plus 3 squared minus 4, which means y equals 2 squared minus 4, which means y equals 4 minus 4, which is 0, correct? All right, well, let's graph those. We got 0, 5, and negative 1, 0. So we had 0, 1, 2, 3, 4, 5. And remember, that's 1, 2, 3 spaces away, so we also have 5 on this side, don't we? Because it's symmetrical. And we went negative 1, 0, which means we also have negative 5, 0. And our graph would look like this. Did your guys' graph look like mine? All right, so you notice anything about that graph?
What's upside down?
It opens up, has a vertex at negative 3, negative 4. What about the x-intercepts? You notice anything about those x-intercepts? What are our x-intercepts? Negative 1, 0, negative 5, 0, right? Up here, when y equals 0, what did we get the solutions for x? What two solutions for x did we get? Does that look familiar? So, when you solve a quadratic equation for y equals 0, what do you end up getting? You get the x-intercepts. We call them the zeros of the equation. When you plug in y for 0 in a quadratic equation and solve for x, you will get the zeros of the equation. And because the vertex is below the x-axis, what do we end up with? We end up with two x-intercepts, don't we? Okay. So let's go ahead and do number 2 together. All right, I'm running out of time, so the rest of these you're going to have to do on your own. So first thing is we're going to undo this just like we did before. We're going to subtract 4 from both sides. We get negative 4 equals x minus 5 squared. And then what do? We take the square root of both sides. Uh-oh. There's a problem here. What's the square root of negative 4? Do we know how to do that? No, that's what we call an imaginary number. It's actually 2 root negative 1, which is 2 root I. I'm sorry, it's 2I. We don't know about that yet. We haven't learned about it. We'll talk a little bit about it this unit. But it's undefined, really, as far as we're concerned. So that doesn't make sense. So there's no zeros to this equation. Let's go ahead and graph it. So what is our vertex? 5, 4, isn't it? Okay, so let's graph 5, 4. 1, 2, 3, 4, 5, 1, 2, 3, 4. Does this guy open up or down?
Down.
What's our A value? What's our A value of this function? 1. Positive 1. So does it open up or down? Up. Let's plug in. Let's just plug in 4 to this equation. So y equals 4 minus 5 squared plus 4, which means y equals negative 1 squared plus 4, which means y equals 1 plus 4, which is 5, right? So when x is 4, y is 5, which means when x is 6, y is also 5, isn't it? So all right, so when we were up here, we said there were no zeros for this equation, right? Because we couldn't solve for negative square root of negative 4. So we said there were no zeros, which means there are no x-intercepts. Man, you guys are on fire today. That's awesome. Okay, guys, the connection we're trying to make here is the solutions to a quadratic equation, the x values. When you plug in 0 for x and you solve, when you plug in 0 for y and you solve for x, those are called the solutions to the equation, or sometimes we call them the zeros to the equation. But what they really are the x-intercepts. And when you try and solve for x in a quadratic equation and you get an undefined, or in this case an imaginary number, it means there are no x-intercepts. Means the vertex is above the x-axis and it opens up, or sometimes it might be below the vertex might be below the x-axis and open down. So there's 3 possibilities when you're solving a quadratic equation. You could end up with 2 x-intercepts. You could end up with 0 x-intercepts, or possibly 1 x-intercept. The 1 x-intercept is when you have your vertex on the x-axis. Okay. So what do you guys think? Should we do another one together, or you want to go on? Okay, let me see what we got back here. All right, I'll do one more with you. All right. I'm going to do the, should I do the hard one with you? I'm going to do this guy over here for you. But what I'm going to do, guys, is just to make things easier, I like it when the zero's on that side. I don't know about you guys, but I like it when it's over there. And it doesn't change anything, does it? Okay. So I'm going to divide both sides by 5. We haven't done that yet, but I want to get rid of that first. What just leaves me x plus 4 squared. What's 0 divided by 5? 0, right? If you had no pizza and you divided 0 pizzas up amongst you and your 4 friends, how much would each of you get? 0. Nothing. Okay? Now we take the square root of both sides, and the square root of x plus 4 squared is just x plus 4. Right? And what's the square root of 0? 0. And since we have x plus 4 equals 0, we're going to subtract 4 from both sides, and we get x equals negative 4. Okay? Finish this worksheet. Let's graph the, what is the vertex, by the way, of this guy? What's the vertex of this equation? Negative 4. What are we adding out here? 0. Negative 4, 0. So negative 4, 0 is right there. Okay, now it doesn't matter whether this guy opens up or down. I think by now we know it opens up. But how many x-intercepts are we going to have? Good luck. How many x-intercepts are we going to have? 1. How many solutions do we have? 1. Okay? And this guy opens up. Let's just try plug it in 2 here. So y equals 5 times 2 plus 2. Sorry, 2 plus 4 squared plus 0. Well, that is going to be 6 squared, which is 36. And whoa, that's going to be a really big number, isn't it? I think we better try 3. So y equals 5 times, wow, still going to be a pretty big number, isn't it?
Still the negative second with positives.
What's that?
This is in like the second quadrant, right? So there's going to be like, wouldn't it be negative 2 instead of positive 2?
No, because it's, well, still it doesn't matter when we're plugging in. We just plug in x values. So this guy shoots up really fast. So, but let's see, 4, 8. Wait a minute, what do we got going wrong here?
Shouldn't it be,
Well,
if you're plugging in 2, shouldn't it be 5 times negative 2 plus
oh, you know what I'm doing here? Thank you. I'm plugging in negatives. Is that what you just said?
Yes.
I'm sorry. I'm trying to hurry because I know I've got like 2 minutes left, so I'm trying to hurry. My bad. My fault. Good job. We got smart kids this period. So we got y equals 5 times, what did I say? Let's go with negative 3 plus 4 squared. So that's y equals 5 times 1 squared, which is y equals 5. That's a little bit better, isn't it? What do we plug in? Negative 3, 1, 2, 3, and 1, 2, 3, 4, 5. It still shoots up there pretty fast, doesn't it? And we would expect it to be pretty skinny, right? Because of the 5. But that is a very skinny parabola. Okay? So what you're going to do is you're going to solve for x here. You should come up with either 0, 1, or 2 solutions. And then those 2 solutions are going to be your x-intercepts, aren't they? So I'm going to leave that one for you. That one, it's a little tricky. You got to do your math. Take your time doing your math. Okay, flip it over. All right, well here you're going to get a lot of practice. A lot of practice. So, you know what, let's just do the evens or the odds. You guys choose. Evens? All right, the evens it is. So you guys are going to do the evens. Do the one on the front, which hopefully it's an even. Let's see, is it an even? Oh, messes up everything. Okay, do the one on the front and the evens on the back. All right? Ready, break.